Good morning, students. Welcome to the statistics class. Today, we are going to learn a new concept or new probability distribution, which is called as binomial probability distribution. Binomial distribution, or I can just call this to be as binomial probability distribution, students. Okay, right? Distribution. By default, it takes a circle, students. If I just connect those two loop kind of a thing, if I just connect it makes it as, it takes by default, it's puts a circle into it, as you have seen. Okay, that is not the one that we have to concentrate on. Okay, so we are learning today, which is called as binomial distribution, students. Binomial distribution. Keep it in your mind, binomial distribution. So for any of the distribution, students, when you want to form any particular distribution or you want to understand the distribution, as I have mentioned in the previous video, the source is important, students. That means how this binomial distribution has been derived. The source will be definitely one random experiment, students. Definitely one random experiment. What is that random experiment? Any experiment which has more than one outcome is called as a random experiment. Okay, but some random experiments will be associated with the distribution, students. Only when you come across or when you understand that what is that experiment, then it will be easy for you to understand what distribution it follows. Okay, so what is that random experiment? Yes, so what is that one? When we have learned one experiment of success or a failure. Is it right? Success or a failure. This is the one of the experiment that we have understood. Okay, success or a failure. Like for example, you have a stone. You have only one stone, students. Remember, you have only just one stone. I'm just giving an example. Take it as an illustration to you. And there is a mango, right, hanging on the tree. Mango, ripened mango, which is there, and you wanted that mango, and there is only one stone. Fine. So what happens is when you do that experiment of hitting the mango, and when you throw a stone, there can be any of the two, right? Any of these two can happen. Either you may become successful or you may become a failure. Successful in hitting the mango or failure in hitting the mango. Is that right? So failure means zero, okay? Or success means one. That means here the range of success that you have it is 0 and 1, students. Is that right? 0 and 1. This is for what? When you have only just one stone, right? And you are aiming at a mango. Is it right? One mango. One stone, one mango. Either you succeed or you fail. So if this 0 indicates what? Failure. 1 indicates what? Success. So that means this is what is the range of success, students. The range of success is either it should take 0 or it should take 1, students. Okay, now let's understand this. What if we have two stones, students? What you have two stones? When you have two stones, okay, so basically the experiment is, right, hitting a mango. So when you are trying to hit a mango, two outcomes are possible. Only two outcomes are possible. Either you may succeed or you may fail. Success or a failure. But when you are doing it, taking two stones, two stones now. You remember two stones. So when you are throwing the two stones, what can be the range of success that we may have it here? The range of success that we may have it here is 0, okay, 0, 1, or 2, students. Why, sir? Why it will be 0, 1 or 2? Because what does 0 indicates? When you are hitting the two stones, none of the stones might have hit the mango. None of the stones may have not hit the mango. So that is the reason the range would be 0. So 0 indicates no stone was hit to the mango. 1 indicates what? Maybe one of the stone might have hit the mango. Chances, one stone may hit the mango. What does that 2 indicates? Two stones may hit the mango. Chances are either 0, no stone may hit. Number 1, one stone may hit. Number 2, both the stones may hit. Okay, so this is what it. What if we have 3 stones, students? What if we have 3 stones? What can be the range of success here? It can be 0, it can be 1, it can be 2, it can be 3. Is it right? Among the 3 stones, 0 indicates what? None of the stone might have hit. There are chances that all the 3 stones may not hit. In the 3 stones, maybe there is a chance that one stone may hit, or 2 stones may hit, or maybe all the 3 stones may hit. So these are the chances, students. Okay. Now, what if we have 4 stones, students? What can be the range of 4 stones hitting the range? Say a range of success would be 0, 1, 2, 3, 4. Is it right? Is it right? So like that, fine. So when you are making the range, right, what if we have n stones? N means any number, but a finite number, students. This is a finite number, a countable number. Okay, so what can be the range? The range can be 0, 1, 2, 3, 4, so on up to n. This is the range of success. Is it right? That means basically the experiment that we are doing is all about the success or a failure experiment only, but we are repeating it many times. We are repeating it twice. Same success or failure time, we are repeating it twice. We are repeating it 3 times. We are repeating it 4 times. We are repeating n times. Success or a failure n times, finite number of times when we are repeating. Such experiments forms what, students? They are called as binomial experiments, students, or binomial trials, right? So one time if you do it, it is Bernoulli trial. If you do only just once, one stone, right, one arrow we have, right, if ever we have only one stone or one arrow and we are trying to do it only once, it is called as a Bernoulli experiment. But if you are repeating that same experiment many times, then it would be called as binomial experiment, students. Okay, right. Now just a refresh. For a Bernoulli experiment, what is the PMF that we have written? We have written it as P raised to x, Q raised to 1 minus x, because only once we are doing the experiment. Is it right? Right? The same thing applies here also, but in a different form. The PMF of binomial distribution. Okay, I'll write this to be as binomial distribution is given as P of x is equal to, remember this, students, NCX, P raised to x, Q raised to n minus x, students. This remains the same, P raised to x, Q raised to n. N indicates why? Because we are doing it n times n minus x. So where x takes the range 0, 1, 2, so on up to n, students, up to n, up to where? Then p is the value always between 0 and 1, students. And how do you find out q? Q is equal to 1 minus p. Now, this is the only thing that we will be speaking about, NCX. This NCX is the combination of success, students. Combination of success, right? I'm speaking about the combination of success. Like, for example, okay, we will be studying in this combination of success. Say, for example, we have 5 stones. Remember 5 stones. And imagine in 5 stones, in the experiment, 2 stones are, if we hit 2 stones, if we hit, now which of the 2 stones, how many combinations can be formed of the 2 stones is what we will be doing. So the combination will be like this: 5C2, Okay, 5C2 means 10. So 10 combinations can be done of two stones together. It may be first stone, second stone, or it may be first stone, third stone. It may be first stone, it may be fourth stone, it may be first one, or it may be fifth one, it may be second one, it may be third one, it may be like that, combination. What are the combinations of success it will tell us. This is what is all about NCX. So basically for this binomial distribution, students, NCX P raised to X Q raised to N minus X is what is important. This is what is called as probability mass function, students, probability mass function. Now, for this, I told you, for any of the probability mass functions, the first thing that you need to remember in that you see is the parameters, students, parameters. Right, parameters are what they are called as. They are called as key elements. They are called as key elements. So when they are called as key elements, what are the parameters of binomial distribution? They are n and p, students. N and p. N indicates what? The number of trials. Okay, number of trials. P indicates the probability of success. Probability of success, students. These two are important elements. These two are very important elements. N and P, they are called as the parameters, students. Okay. So now what we'll be doing is we will be learning. The next thing is the mean. Okay, the mean. What is the mean? Mean of binomial distribution, that is expectation of x, is right n into p, students, np. Okay, then the variance is given as n into p into q, students. Variance is given as n into p into q, and the standard deviation is given as standard deviation of x is given as root of npq. Okay, so like that, students, you need to remember. So what is the PMF of a binomial distribution? PMF of a binomial distribution is P of x is equal to NCX P raised to x Q raised to N minus x. So what is the range of x? X ranges from 0, 1, 2 till where? Till N. And you know what is a P. This is what you need to remember, students. Apart from that, students, apart from that, we have certain things also we need to remember. Okay, we need to remember certain things. Like for example, I'll just show it to you here. There are some points that you need to remember. Okay, there are some points, students. What are those points? It's here. Okay, the first thing is, what are the examples that comes under? What are the examples that come under here? It's been given here. See here. First one, number of heads among 4 tosses. Toss of a coin has 2 outcomes. Either we may get head or a tail. Is it right? 2 outcomes. Like that, we are doing it for how many times? How many tosses? 4 tosses. Right? Male children in a family of 2 children. A child can be either a male or a female, students. 2 outcomes. So like that, we are testing for how many children, right? In a family of 2 children, students. Okay, right. Number of bombs hitting a target among 3 bombs which are aimed at it. Bombs, dropping a bomb, and when you do it, either you may hit or you may not hit, students. Okay, 2 outcomes are possible. Like that, success or a failure. Like that, they are doing it for how many times? 3 times. Number of defective articles in a random sample. So an article, if you speak about an article, it can be defective or it can be non-defective. Two other things can be possible. Either it should be defective or non-defective. So if it is a defective, it is a success. If it is a non-defective, it is a failure. Like that, they are testing for how many articles? 6 articles, students. Okay, so now when you're speaking about the next example here, number of seeds germinating among 10 seeds. A seed, when it is planted, it has 2 outcomes. Either it opens up and germinates, or it may not germinate. Okay, it may not, or it may die. right? It may grow up, it may become a plant, or you may not see any plant. That means the seed has not given any uh, you know, any growth. So that's what you can say. Either of the two outcomes are possible. Like that, if you do it for 10 times, finite number of times, these are all random experiments. Success or a failure experiment, doing it many times, they all comes under what, students? Binomial distribution, binomial variate. Okay, so this is what you need to understand. Okay, so when you come across this kind of an example, students, I would just like to share even this also, students. Here, what are the features? I have already mentioned two or three of them. Let's learn few things here. The first thing, you see, N and P are the parameters. Okay, N and P are the parameters. The range, you have seen that it goes up to N. Fine, we can write a binomial distribution. This is a PMF of it. I have told about the mean and variance also. And when you remember, in this, always in a binomial distribution, mean is always greater than variance. NP is greater than NPQ. Is that okay? So these are some of the points that you should remember, students. Okay, so one more thing that you need to always remember is these are some of the points. Okay, these are some of the points. The first thing is the mode of the distribution. Okay, the mode of the binomial distribution, it's clearly here, it's mentioned here. The mode of the binomial distribution is equal to the value of the x, which has the largest probability. Whichever x value has the largest probability, that value itself is the mode. So here they also mention that if both P and Q are equal, the binomial distribution is symmetrical. I will explain that to you when in the next, or in the video where I solve the problems on binomial distributions. I will explain that to you what it is. And if it is less than half, if P is less than half, either of it you remember, if P is less than half, right, then binomial distribution is positively skewed. If P is more than half, binomial distribution is negatively skewed. Okay, so this is what it is. And even if ever we are doing it, these things and all comes under in the next trial when we just do it. I will explain that to you in detail. You will come to know. In other words, the next distribution is Poisson distribution. Binomial distribution also has some limitations. When it goes beyond that limitation, it enters into a new distribution, and which the distribution it is called as a Poisson distribution. Like that, there are certain things that we need to learn. Okay, so these are some of the points that are to be understood by each and every one of us, students. Okay, right. Then there is something called a recurrence relation for successive probabilities. If ever the probabilities of x, the values of x are 0, 1, 2, so on and 4 and 5, so many values we have to find out. If we find out the first probability P of 0, right, then continuously we can find out all these successively, all these probabilities using this relation. Instead of using that probability mass function, you can use this function, and successively we can find out all the probabilities here, students. Okay, likewise we have some frequencies also. To find out successive frequencies, we have this formula as n minus x plus 1 divided by x into p by q into t of x minus 1. This is the formula that can be used to find out the successive frequencies. How many times this can has happened? One time. How many times? If ever we are doing it, some kind of tossing a coin. Say for example, we are tossing 200 times the coins. Okay, how many times you got no heads? How many times you got one head? How many times you got two heads? How many times you got three heads? If you're doing it for four coins, if you're tossing four coins and doing it for 200 times, so you should understand that what is it is all about. How many times you have got two heads, how many times you have got three heads, how many times you have got four heads. Like that, to know, we use this relation which is called as recurrence relation for successive frequencies, students. This is what we have in the theory regarding binomial distribution. So in the next class, we will start with 1 mark, 2 marks problems, and then proceed with 5 and 10 later. Okay, thank you for hearing and patiently listening about this explanation. I want you to go back and once again watch this video so that you could better understand about binomial distribution, which is very important for us, okay, which carries a good lot of marks for the final examination. And this is the chapter that you can score well and get, maybe you can score out also, so chances are there. So please do follow this video once again. Thank you, students. Thank you very much. Have a nice day.